the common room.
Yeah, okay. You know that this is a video recording, so
Yeah. Please.
It is nice commitment.
No. I am aware. So please feel free to remind me whenever we can go back to offline.
There is nothing embarrassing about what we discussed, but it's time for us to get back to business.
Oh yes, please. Sorry.
Silvia, good evening. My name is Leonid Polishuk. I'll be chairing your presentation. We will begin in just 1 minute. If you can, please stay within 45 minutes or so when you're presenting. And then please keep an eye on the chat column of this Zoom session because people might be asking questions in chat. Up to you whether you answer these questions immediately or put them off until your presentation is over. And my conventional reminder to everyone to please register yourself in the very same chat call.
Silvia, I will keep an eye to the chat, and if I see any questions, I will let you know, and then you can choose if to answer it right now or later.
That should be extremely helpful. Okay, well, good evening, everyone. Welcome to our next seminar of the Center for Institutional Studies at the HEC University in Moscow. Tonight, we are very pleased to have as our speaker Silvia Griselda from the University of Melbourne, Australia. She is a PhD candidate at this university, as far as I know. She also received Masters in Economics from the same university. Her early degrees are from Venice, Italy. And Silvia works in the fields of economics of education, gender, and labor. Her presentation tonight is about gender gap and the framing of questions in mathematical tests. So we very much look forward to that. Thanks very much, Silvia.
Thank you, Leonid. So thank you everyone for having me. So today I will present my job market paper titled Different Question, Different Gender Gap. Can the format of question explain the gender gap in mathematics? And this paper analyzes whether standardized assessment, which are screening technology that are commonly used in university admission and job. This paper tries to understand whether these standardized assessments are accurate measure to measure boys and girls' level of knowledge. And the motivation for this paper arises from the fact that nowadays, despite catching up in most educational outcomes, girls still underperform boys in mathematics. And this has important implications for both women and the society, as mathematics skills play a crucial role in determining future earnings and entrance into highly paid STEM occupation. But what if the way we measure students' performance can themselves amplify and reinforce gender difference in mathematics performance? This paper analyzes exactly this issue by analyzing the role of multiple choice standardized assessment in explaining the gender gap in mathematics. So nowadays, standardized assessments are widely used to determine education and economic opportunity. Few examples of these are the SAT and the GRE test, which are screening technology for admission to undergraduate and graduate programs. Other examples of standardized assessment are the IELTS or TOEFL, which are standardized assessment that are used for the provision of English license. And other examples are the huge international standardized assessments such as Pisa and TIMSS, which are used to compare performance of students across country and across gender. These standardized assessments employ totally or in large part multiple choice questions, as this kind of questions are considered objective, easy to implement on a large scale, and also low cost. Especially in terms of marking, they are seen as low cost, impartial, and also less subject to human manipulation, especially when multiple choice questions are marked through a computer. Nevertheless, there is limited understanding whether multiple choice assessment can capture difference in individual competences or their performance are affected also by difference in individual answering strategies. So this paper answered 3 questions. First of all, in a context where students do not receive any negative marking for choosing the wrong answer, do boys have an advantage in multiple choice question? And in answering this question, I will try to distinguish between question difference in area of assessment and difference in individual answering strategy. Once I determine whether boys have an advantage in multiple choice question, I move on and I try to understand whether the proportional multiple choice question that students receive in their test has an effect on overall performance and also performance on other format of questions. And in order to answer this question, I exploit the random assignment of different exam booklet with different proportional multiple choice question to students. Finally, I investigate one of the possible mechanisms, which is whether the proportional multiple choice question that students receive differentially affect the girls' and boys' level of effort during the test. So let me tell you a little bit the preview of findings. With respect to the first question, whether boys have an advantage in multiple choice question, I do find that indeed boys have an advantage in multiple choice question, and this advantage is not driven by multiple choice question assessing specific skills where boys are better off, neither are driven by boys' lower writing skills. Secondly, I also find that the proportion of multiple choice questions has an effect on girls and boys' performance. In particular, I find that a 10 percentage point increase in the proportion of multiple choice question in mathematics that students receive increase the gender gap in mathematics by 0.026 of a standard deviation in favor of boys. This means that the performance of girls differentially decrease compared to the one of boys when the proportion of multiple choice question in the test increases. And this effect is about 50% of the baseline result and correspond to an increase in the class size of one pupil or a decrease in teacher quality of 1/4 of a standard deviation. Not only, I also found that the proportion of multiple choice questions that students receive in their exam affect the performance on also other format of question. So the proportion of multiple choice question has spillover effect on other formats. Finally, I also find that the proportion of multiple choice question differentially affect girls' level of effort during the test. So before I move on, do you have any question? Okay, feel free to interrupt me at any time. So let me tell you a little bit about which literature I contribute and what the literature has studied so far. So I contribute to a wide literature in education that documented that there is a gender difference in performance by format of the exam. And in particular, this literature documented that boys perform better in multiple choice question compared to construct response question. There are different reasons why boys may perform better in multiple choice question. First of all, boys may be better in skills that are commonly assessed using multiple choice question. And the literature has widely analyzed that boys tend to be better than girls in identifying reasonable response, which is a skill that is usually assessed using multiple choice question. If this is the case and boys have an advantage in multiple choice question for this reason, then the performance of multiple choice question are not biased. They are just capture different skills. Nevertheless, boys may have an advantage in multiple choice question if they have answering strategy that are beneficial in answering multiple choice question. And the literature shows that boys tend to omit less question and guess more often than girls. Nevertheless, the literature wasn't able to understand and differentiate between gender difference in area of knowledge and gender difference in individual answering strategy. I contribute to this literature by differentiating between these two factors and showing that not only boys perform better in multiple choice question, but also the proportion of multiple choice question that you receive in a test has an effect on your performance and level of effort. Secondly, there is a wide literature in economics that shows that in presence of negative marking, multiple choice question decrease women performance. Indeed, women tend to be more risk averse. So in presence of penalty for wrong response, women tend to omit question more often, and this has a detrimental effect on their performance. I contribute to this literature by showing that the effect of the boys' advantage in multiple choice question also persists once negative marking is removed. And I also analyzed the effect of proportional multiple choice question. Okay, let me move on the data. So in order to analyze these questions, I use data from the Pisa 2015 International Assessment, which is the largest international assessment that every wave assesses more than 500,000 15-year-old students in 65 countries. In 2015, the test was computer-based, so students answered the test through a computer. And each wave, the test aim to assess students' knowledge or proficiency in mathematics, reading, and science. This test is a low stake for students in the sense that performance in Pisa has no direct effect on any student's outcomes or educational and labor outcomes. Nevertheless, Pisa is widely used for governments and policymakers to compare performance of students across country and also within country across different groups of students. My data contain information on each question, specific information. I have students' performance in each question and in the overall exam. Because the test is computer-based, I also have information on the time undertaken to answer each question and whether the students answered the question or not. I also have information on students' demographic characteristics and, of course, schools' characteristics. In Pisa, the population follow a two-stage stratified design. In particular, in each country, 150 schools that have 15-year-old students are randomly selected with a probability that is proportional to the school size. Within each school, around 35 students are randomly selected with equal probability. So this is a little bit the timeline of the test. So the entire test lasts 3.5 hours, but the actual assessment lasts 2 hours with a 5 minutes break between the two, between 1 hour and the second hour. There are 4 sections in the test, so 4 30-minute sections, which are called clusters, and these clusters contain our section in science, mathematics, and readings. The test is monitored by trained test administrator, which who cannot be a teacher of participating students. And each students are randomly assigned to one of the possible 396 booklets, which are different combination of 12 science, 7 mathematics, and 7 reading clusters. So let me show an example of these different booklet combination. So here I have booklet A, B, and C, which are randomly assigned to different students. Each booklet have 4 clusters, which are these 4 30-minute sections. And in this case, I see that the students that receive booklet A answer the mathematics question in the second 30-minute section. The second students, which receive the booklet B, answer the exact same question, but in different order. So for example, it's gonna answer the mathematics section in the second half of the exam, so in the third section or the third cluster. And then I have students that receive booklet C that completely answer different kind of question compared to the previous students. Each section or cluster lasts 30 minutes and has between 12 and 13 questions, which are chosen among a total pool of 81 mathematical questions. The Pisa assessment tests students using 3 different formats of questions, so multiple choice, closed response, and open response question. So let me show you and let me clear what are these formats of the question. So this is an example of a mathematical question, a multiple choice question. Students have the prompt of the question, and then they need to choose one possible answer among the set of 5 possible answers. The second type of format is a closed response question, where students still have the question prompt and they need to provide a short and concise answer. So in this case, it's just a number. And then I have an open response question where students have the prompt. They need to provide a concise answer, so the number of year, alongside a detailed explanation of their reasonings. So the difference between closed and open response question is that closed response question, students need to come up with an answer, but the answer needs to be short and concise. While in open response question, they need to come up with an answer alongside a detailed explanation on how they reach that answer. So here, this figure shows the variation of proportion of multiple choice, closed response, and open response question in the different combination of mathematics booklet. And here I see that the proportion of multiple choice question in blue vary between 29 and 70%. So students need to answer the question in the order that they are given. So they need to answer, they cannot answer a question and then go back. This, and the students do not receive any feedback whether they answer the question correctly or not. Multiple choice question and closed response question are coded through computer, while open response question are marked anonymously by training coders. So each training coders receive about 100 questions, which are anonymously and randomly selected. So we shouldn't expect any bias in the marking or manipulation in the marking. Any question up to now?
I don't see any, so please continue.
Thank you.
Sure.
So let me go to the first question, whether boys have an advantage in multiple choice question. As I was telling you before, there are 2 main reasons why boys may have an advantage in multiple choice question. First, boys may be better off in an area of knowledge, process, cognitive process that are commonly assessed using multiple choice question. Secondly, they may have an advantage in multiple choice question because they omit less question or they guess more often. Here, I'm able to distinguish between these 2 mechanisms by using exact information for each content, context, and cognitive process that each question aims to assess. In particular, Pisa provides information for each question for which skill the question aims to assess. I'm going to control for these question characteristics and show the whether boys have an advantage or not in multiple choice question. Secondly, boys may also have an advantage in multiple choice question because they have lower writing skill. In order to isolate the role of writing skill, I compare multiple choice question not with the all constructed response question, but rather with closed response question. So remember that in closed response question, students are not required to write a long explanation, but just a short and concise answer. So by comparing boys and girls' performance in multiple choice and closed response, I should be able to isolate the role of writing skills. So this is the regression analysis that I run. It's just simple regression analysis when I have whether the question Q answered by students I in school S is my outcome and whether it's correct or not. And the explanatory variable are a dummy for female, a dummy for whether the question is multiple choice question or open response question. The baseline category in this case is closed response question. And then I have the interaction term between female multiple choice and female open response. As I was telling you before, I do control for each set of question characteristics in order to isolate this role of multiple choice question assessing specific areas of knowledge where boys are better off. I also control for several students' characteristics and school fixed effect. So this is a simple table that is useful for me to understand how can I interpret this estimate and what is the gender gap. So in particular, the difference between female and boys' performance in closed response question is going to be captured by the coefficient alpha 1. The gender difference in multiple choice question alpha 1 plus alpha 3, and the gender difference in open response question alpha 1 plus alpha 5. So I'm not going to show you the table of result. I'm going to show you the adjust picture. Remember that in this picture, I control for question characteristics. And here, what we see is that boys perform better than girls in mathematics in all formats of the questions. Nevertheless, the gender difference is wider in multiple choice question compared to closed and open response question. This gender difference cannot be driven by, or shouldn't be driven by writing skill, as if we compare the gender difference in multiple choice and closed response question, we see that boys' advantage is bigger in multiple choice compared to closed response question. So it does seem that boys indeed have an advantage in answering multiple choice questions. Secondly, I want to understand whether the proportion of multiple choice question that students receive in an exam has an effect on their performance. And in order to answer this question, I exploit the random assignment of different exam booklets with different proportion of multiple choice question to students. So here I'm comparing the gender gap among students that receive 55% of multiple choice question and the gender gap among students that receive an exam booklet with, for example, 40% of multiple choice questions. And here is my empirical estimation. So my outcome of interest is Y, which is the proportion of correct question standardized for students I in school S that receive booklet B. My main explanatory variable are again female and the interaction between female and proportional multiple choice question. Here I control for booklet fixed effect. So the proportional multiple choice question is gonna capture by this booklet fixed effect. And I control for several students' characteristics and school fixed effect. Let me spend a few words about the outcome of interest. So Pisa measures students' performance using the item response theory. This means that for each student, the performance are computed using how well he answered each question and also how similar students answer different questions. So Pisa provide, from this item response theory, provide the average of plausible value. I don't think this average of plausible value is an appropriate outcome in my case, because in my case, I want to understand the proportion of, whether the proportion of questions that students receive has an effect on his performance. So I'm not interested on how similar students answer a different kind of question. Nevertheless, my main table of results report the Pisa score and the results remain robust. But my preferred specification use the standardized raw score. So the proportion of multiple choice, proportion of correct question answer standardized to have a standardized measure of performance. And this is my table of results. So in table 1 and 3, I have the result for the raw score, so the proportion standardized and the average plausible value without using school fixed effect. while column 2 and 4 uses school fixed effect. My preferred specification is in column 2. So let me help me to interpret this coefficient. This coefficient means that when the proportion of multiple choice questions that students receive in mathematics increase by 10 percentage points, the performance of girls differentially decrease by 0.026 of a standard deviation. Not only am I interested in the overall performance, but also I am interested on how the proportion of multiple choice questions affect correct number of multiple choice, closed response, and open response question. So this picture plot the same two estimates that I showed you in the previous table, these two estimates here, but using 3 different outcomes. So proportion of only multiple choice, proportion of only closed response, and open response question.
Sorry, Silvia, I have a quick question. Yeah. I might have missed. Can you go to the previous slide? I'm not sure if I misunderstood something, but you said like 0.026 or 0.026 or 0.026?
Yeah. So here the proportion of multiple choice question. Thank you for the question. So the proportion of multiple choice question is a value that goes from 0 to 1. Mm-hmm. So if the proportion of multiple choice question increase by 10 percentage point, so by 0.10, then the correct is 0.026.
Okay,
so this estimate times 0.10. Yeah. Thank you for asking. Yeah, so here I plot these two estimates for a different format of question. And what I see is that if the proportion of multiple choice question increase, then the performance of girls differentially decrease also in closed response and open response question. This means that the proportion of multiple choice question has negative spillover effect on how students, and in particular how female students, answer other formats of questions. Note that the estimate for multiple choice is statistically insignificant, so it's statistically not different from 0. This doesn't mean that female perform as well as boys in multiple choice question. No. Female perform worse than boys in multiple choice question, and this effect is captured by the estimate of female. But this girls' lower performance does not vary when the proportion of multiple choice question increase. Any question? I think I can move on.
I don't see any questions.
Okay, so let me spend a few minutes talking about possible confounding factors that could drive my result. So here I report my estimation. Remember that I do have booklet fixed effect, so this should capture any difference in booklet characteristics. Nevertheless, there could be some confounding factors, so omitted variable factors that are correlated with the outcomes and differentially affect the boys and girls' performance. So there could be characteristics of the booklet that affect the boys and girls' performance differentially. If this is the case, then my result could be biased by this omitted variable. So the first thing that I want to analyze is whether the proportion of multiple choice question is correlated with the proportion of, for example, open or closed response question. So in order to show that my results are not driven by the proportion of other format of question, I estimate the same table before with including both proportion of multiple choice question and proportion of open response question. So here the baseline category is again closed response question. So here I see that if I include the proportion of open response question, my result become even bigger in magnitude. So this means that what drive my result is the proportion of multiple choice question, and also, if you want, the proportion of open response question. Female perform better in comparative term if they receive a higher proportion of closed response questions. Secondly, I also analyze the role of number of question and question difficulties. So different booklet and booklet with a higher number of multiple choice question could have more or less question in general, or could have questions that are different in terms of characteristics. Here I show that the proportion of multiple choice question is not positively correlated with the number of questions in the cluster. If anything, is negatively correlated, so should be downward bias my estimate. More or less, the proportion of multiple choice question has no effect on the average question difficulty in the booklet or the number of easy, medium, and hard questions. So this shouldn't drive my result. Also, the order of question could confound my result. In particular, multiple choice question may appear in a specific position within a cluster. So, for example, always at the beginning or always at the end. And a previous literature shows that the position of the question in the test has an effect on students' performance. This per se shouldn't be a problem in my estimation, but it's a problem if it affects students' performance differentially for boys and girls. And previous literature shows that indeed the item position within an exam has a differential effect on girls and boys' performance. Usually boys tend to decrease their performance over the exam, while girls are better in sustaining their performance through the test. So girls do equally well during the entire test, while boys do really well at the beginning, but then they decrease their level of performance. If this is the case, then my position within the cluster should drive my result. What I show here is that there is no correlation between the sequence of the question in the cluster and whether the question is multiple choice question or not. So multiple choice questions do not appear in a specific position within the cluster. I also analyze whether they appear among the first 3, the second 3, the third 3, and the fourth 3 questions, and I don't find any correlation. So this shouldn't drive my result. So after showing that these confounding factors are not driven my result, what I also want to show you is that my results are not driven by gender difference in motor skills. In particular, boys may be, so remember that here students are typing the question, and boys may be less able than girls in really typing the question. In order to show that these are not driven my result, I show that I find similar result when I use data from the Pisa 2012 assessment. So the wave before mine. In the way before 2015, the Pisa 2012 assessment was done using paper-based exam. So students just need to write down their answer using a pencil. The result remain robust if I use his performance. Could also be that my results are driven by gender difference in reading and writing skills. In particular, could be that multiple choice questions have longer prompt, so students are less able to perform well in a reading question, or could also be by writing skills. In order to show that these do not drive my result, I show first of all that my result remain robust if I control for students' reading scores. But remember that my estimation strategy was exploiting the random assignment of different booklet to different students. So again, I find evidence that controlling for reading score does not drive my result. Secondly, as I showed you before, my results are not driven by open response, but they are rather driven by closed response. So when I control for both proportional multiple choice and open response question, I find that my result, if anything, become even bigger. Okay, I think I can move on try to understanding why the proportional multiple choice question affects students' overall performance, but also has spillover effect on other format of question. And in particular, I analyze whether the proportional multiple choice question has an effect on students' level of efforts for boys and girls. In particular, Pisa is a low-stake exam for students, as I was mentioning before. Therefore, boys and girls may have different level of incentive to put effort in the test. In particular, previous literature has shown that boys tend to perform better in high-stake exam, while girls tend to perform better in low-stake exam. What I do here is I follow the literature, I identify whether a student is low effort, is exerting low level of effort or not, and then I look at whether the proportional multiple choice question has an effect on boys and girls' likelihood to exert low effort. So let me spend a few words trying to mentioning to you how I identify whether a student is exerting low effort or not. I look at two criteria. First of all, I look at whether a student omit or skip 3 or more questions in his section, even if there is enough time left to answer. So if you skip more or 3 questions, then I consider these students as low effort. Secondly, I also look at the time spent for each question and whether a question was answered too fast. In particular, students need to read and think about a question carefully before answering. So if a student answers the question too fast, that not even enough time is given to read the question or think carefully, then I can consider this as a sign of low effort. What I do is I flag whether a question is answered too fast or not using time response data. And I consider a student as low effort if he answers 3 or more questions too fast. And the proportion of correct question answered too fast is lower than the proportion of correct question answered in normal time. Also, let me spend a few minutes telling you how I compute the threshold of too fast. Again, I follow the literature, and for each country and for each question, I compute a threshold that determines whether the question is answered too fast using the 10% of the average time spent for this question. So for example, me, Silvia, I answered the question number 1 in Italy. And in Italy, the average time to answer question 1 is 2 minutes, so 120 seconds. If me, Silvia, answer the question 1 in less than 12 seconds, so in less than 10% that the average time that is spent in Italy to answer question 1, then I'm answering this question too fast. If I'm answering 3 or more questions too fast, then I am considered as low effort student. And here, what I do is exactly as a table similar to the table before, when as my outcome variable is whether the student is considered low effort or not. And here I see that, in general, consistent with the literature, females are less likely than boys to be identifying as low effort. Remember that this is a low-stake exam, so this is consistent with the literature. But when the proportional multiple choice question increase, females are more likely, and in particular differentially more likely than boys, to be identifying as low effort. And this, look at that, this estimate is the opposite side and almost double in terms of magnitude. So this effect is pretty significant. Okay, let me spend a few words to try to understand why the gender gap in mathematics may vary with the proportional multiple choice question. In particular, performance of multiple choice question may depend on students' willingness to guess, which in my test is likely to depend on students' level of confidence in mathematics. Remember that in my context, there is no negative marking, so risk aversion shouldn't play a role in guessing. But what can play a role is how much confident you are in the answer. And previous literature has showed that boys tend to be more confident than girls in male type domain, such as mathematics. Secondly, also unintended corrective feedback should play a role. So unintended corrective feedback is a concept that refers to the fact that in multiple choice question, students are able to realize that their computation or their answer is wrong once this answer does not appear among the set of possible ones. Students may have a different reaction to negative feedback, in particular due to the role of self-stereotypes. Because the girls tend to believe, or students believe that girls are worse than boys in mathematics, girls are more likely to attribute negative feedback to their lower mathematics ability. Ideally, I would like to have measure of students' level of confidence and students' level of self-stereotypes or a belief about boys being better than girls in mathematics. I don't have this measure in my database, but what I do is try to use maternal STEM occupation as a proxy for students' confidence and beliefs about the boys' greater ability in mathematics. In particular, previous literature shows that students whose mom work in STEM-related occupation tend to have a higher mathematical confidence, and also they are less likely to believe that boys are better than girls in mathematics. What I do here is I estimate my result for students among students whose mom does not work in STEM-related occupation and mom that work in STEM-related occupation. And I see that my results are entirely driven by students whose mom does not work in STEM-related occupation. Once I consider students whose mom work in STEM-related occupation, my result, so the effect of proportional multiple choice question, completely disappear. So this is an evidence that among students with higher mathematical confidence or lower beliefs that boys are better than girls in mathematics, the proportional multiple choice question that they receive in this test does not have any effect. Okay. Let me conclude. I think I am on time. So what this paper does is demonstrate or provide evidence that the screening technology that are commonly used for assessing students' gender gap, but also to screen and to determine admission to schools, but also to jobs, may not be the accurate measure to assess students' underlying knowledge. In particular, boys have an advantage in multiple choice question, not only, but also the proportional multiple choice question affect students' overall performance and performance in other format of questions. This is mainly driven by the fact that girls tend to put less level of effort in the test when they receive a higher proportional multiple choice question. This effect disappears among students whose mom work in STEM-related occupation, so students with higher confidence in mathematics and lower self-stereotypes. So thank you, and I'm gonna finish here.
Excellent, thanks very much, Silvia. Now we know why there is a gender gap in math tests. All right, if there are any questions, any queries, any comments?
I have one quick question just out of curiosity. Is there like any proportion of like multiple choice versus other type of questions that would like close completely the gender gap in the Pisa, or even provide a gender gap in favor of females, or is it not, or even if you like make no multiple choice, there will still be some sort of gender gap?
So here, so let me show the table of result. So from this table of result, here you see the estimate for female. So this means that when the proportion of multiple choice question is equal to 0, so students do not receive any multiple choice question, there is still a gender gap. So in particular, girls are 6% less able than boys. So they perform 6% lower. They have a number of correct questions that is 6% lower than the one of boys. So a gender gap does exist, but this is amplifying by the use of multiple choice question.
If I may ask, if there is any penalty for wrongly answered questions, in other words, if I don't know an answer, if I guess, are there any risks? Because
no. So in this context, in this context, students do not receive any penalty for choosing the wrong answer.
Right. So just guessing is a much better strategy than not answering at all, right? Is that correct?
Yeah. So it should be a weakly dominant strategy. Nevertheless, many students still omit several questions. This could be a sign of low efforts, but not only. So the fact that girls omit more questions even when penalty is not applied is something that has been documented in the literature.
And are there any explanations why they do it? Because it doesn't seem to be rational.
At the moment, at the moment, there is no clear consensus of why they do that.
Maybe they're just more responsible for giving correct answers. They want to be more confident, so it might be psychological then.
That's what I think. That's what I think as well. Could also be that they spend more because they have a set of possible answer. They spend more time to understand what is the correct answer. They are less confident, so they really spend a lot of time, and they are kind of adverse to the ambiguity of having several possible answers. Yeah.
Because you ascribe this phenomenon to boys being more confident in their math knowledge, which might be the case, but another possible explanation is that boys are just a bit more audacious. They don't quite care. Girls would think hard before answering. If they're not confident, they wouldn't answer at all, but boys will go ahead and just give an answer. And as a result, they outperform.
Yeah.
Okay, well, thanks. Please, anyone else?
So my understanding is that you run a regression keeping the non-replied as incorrectly replied, right?
Yeah, yeah.
So did you try running a regression when you just drop the ones that people did not reply?
Yes, I did. So here I use, so before I didn't show you this table, I show you the graph. The result remain exactly similar when I use as outcome, not only correct answer, but correct answer conditional on answering. And here the result remain similar. So I don't think that omitting is what drives my result.
Thank you.
Please, any further questions?
Silvia, thank you for this interesting presentation. And so maybe I missed this in the beginning of the presentation, but is there any difference between countries, and what country data did you use?
So here I use all the country that use computer-based assessment. So there are more than 50 countries in my database. There are, first of all, in my estimation, I do control for school fixed effect, which kind of capture country fixed effect as well. So my results are not driven by difference by country. But there is heterogeneity, different effect by countries. So at the moment, what I want to try to do is trying to understand whether this difference by country, it's correlated with, for example, country gender norms or this kind of thing. At the moment, I find that there is a correlation, but it's not significant. So I need to understand what's going on. So could be that another way to think about this is here using, so previous literature as using, instead of using all students in the country, students using second generation students in the country, and using the norm, the gender norm in the home country of these second generation students, and try to understand whether these gender norms are correlated with my effect. The problem is that if I do that, I don't have enough observation. Then I lose a little bit of, so I need to think how to, I want to discuss about this heterogeneity across countries, but there is some heterogeneity, yeah. Thank you, Victoria.
Thank you too.
Excellent, please. Silvia, did you try to control for students' performance in other subjects, not in math? That can give you some measure of their general cognitive ability and see how that plays out in this gender gap?
So yes, I did. So what I, let me see if I find the table. I did. So remember that the Pisa assess students' knowledge in readings and science. I find that my results are not positive in reading, but they are in science. And this is true for both 2012 and 2015. Nevertheless, I decided to focus in mathematics for two main reasons. First of all, mathematics is the domain where there is a wider gender gap in favor of boys. There is no this gender gap in reading, where girls perform better than boys, and there is no gender difference in science. Secondly, in science and reading, there is no many close response question. Because I wanted to exploit the free format of question, I focus on mathematics. But my result persist in science while they disappear in readings. So maybe I find the table. Let me see if I can find the table.
Well, I guess I asked a slightly different question. It's not whether you observe gender gap in other fields, but what happens if you try to explain the gender gap in math in answering multiple choice questions, but in this regression you include among your control variables the students' results in other fields. So it would be just your control variable. You explain the gender gap in math, but among other controls that you also include the students' performance in other disciplines. It might be interesting to see if that makes any difference.
Thank you. That's a good point.
Because this data is immediately available, right?
Yeah.
Same data gives it to you.
Yeah.
All right. Okay, well.
I have another question.
Yeah, sure.
Sorry, I know that at the beginning, when you were presenting like the main results, you mentioned like you started comparing your estimates with other like, let's say, magnitudes of the literature as teacher quality, but I couldn't I don't remember the number. So can you refresh me, please, on this, like to give more context on the size of your findings? Yeah.
So remember that a 10 percentage point increase the proportion of multiple choice question, differentially decrease girl performance by 0.026 standard deviation. This corresponds to increasing the class size by 1 pupil or decrease the teaching quality by 1/4 of a standard deviation.
Okay, yeah. Thanks.
Yeah. For girls, of course, right?
Yes,
because
yes.
the performance, yeah.
Sorry, one related question. So I'm not sure exactly how to phrase it, but for example, let's assume that all these children were like, so let's assume that this Pisa exam was like admission to higher education, and so different people receive different booklets. So like, how does, like, I don't know, like, by increasing or decreasing 10% of multiple choice, like how many more girls would be admitted in higher education or how many more boys would be admitted? Like, can you give an idea on this line?
I need to think about that. So there are two things that I want to mention. I think that to think about that, you need to keep, like, to fix a level of threshold. For example, students above 70% are admitted. And also, I think what I want to do is try to understand at which level of the distribution, of the ability distribution, this effect of proportional multiple choice question play a role. So if it's only for really high ability students, or if it's low ability students. This is something that I want to do. It's not so straightforward, so I'm still thinking on how I have to do it, okay. But this is a good point. Yeah, it's a good point that I want to think more about that, yeah.
Thanks.
If I may, let me ask you a general question, just your opinion about this. That girls underperform in this math test is an outcome of some, market failure. It's not because they're weaker cognitively or intellectually or otherwise. It's just a matter of psychology or a matter of a little bit of learned helplessness and so forth. Can you think about some policy measures to fix this? About some kind of, I hate to say that, affirmative action that would support girls, give them some additional advantages to make it a more level playing field? These are low stake, you said, low stake exams because they really don't matter for the children involved, but some other exams are not, like tests that people take before being admitted to colleges, so forth. And if there are some systemic gaps which have little to do with the abilities and talent and aptitude and whatnot, can you think about some corrective measures? Would those be appropriate?
Yeah, so I think this is a good question, and I don't think there is a unique answer. So one thing could be like, don't use multiple choice question, but I don't think that's the only measure to think about, in the sense that if multiple choice questions are effectively less costly than other format of question, then we need to think about a cost-benefit analysis. I think to answer this question, we really need to understand what are the mechanisms behind the boys' advantage in multiple choice question, and, for example, improve the level of confidence for girls and decreasing their stereotypes, their self-stereotypes, that boys are better than girls in mathematics may help. Remember that in my analysis, I find that the effect is not there among students whose mom work in STEM-related occupation. So these, by increasing female confidence in mathematics, but also providing them more opportunity to answer multiple choice question, kind of teaching them how to answer multiple choice question, this could be another strategy.
Okay.
I have one question more.
Please.
Silvia, do you have some other social characteristics of these children? Maybe family income or something on?
Yeah, I do.
And did you check some of them?
What do you mean by did you check?
Did you check relations, for example, with family income? I mean, this gender gap correlated with other social characteristics?
Yes and no. So first of all, my regression does control for the parent education, occupational level, and also Pisa provide a measure of socioeconomic status. So I do control for this in my result. I also control, for example, whether the proportional multiple choice question affect differentially immigrants and non-immigrants or low and high SES students. I don't find that this drive my result. So yeah.
Thank you.
Yeah, I don't know. One thing that I want to check is whether the gender gap is more wider for among girls and boys immigrants. That could be another thing. I didn't do this kind of two-way relationship. That's something I can do.
Very good. Any further comments? It just occurred to me that there is another area when there was a perception, a stereotype, that girls, or for that matter, women, underperformed in relation to boys or men, and this is chess. Just by coincidence, yesterday I watched a show on TV, Christiana Manpur, a journalist, she has her show, and on that show she put Garry Kasparov, who is a former world chess champion, and Judith Polgar from Hungary. She's an excellent chess player, and she won over Kasparov several times, and Kasparov was cited in the late 1980s as saying that women will never be able to play competitively with men for whatever reasons, and then he had to acknowledge that he was wrong. And in particular because he lost to Polgar quite a few times, but at the same time he hurried to say that no, our overall score is positive in my favor, but nonetheless there is a much more significant presence of female chess players in international contests, and I think this gap is being eliminated, which might have to do with confidence of women and the perception they can do just about as well as men. So there might be some other, some similar reasons for this learned helplessness, which people overcome by way of experience and by simply showing that, yes, we can. Okay, well, I don't see any further questions. I think it was a very useful discussion, very insightful. Thanks very much, Silvia. I appreciate this for finding time to give a presentation of this seminar, and do stay in touch. I guess I would also say that you might want to have a look at Russian data, because in Russia, every student has to take a comprehensive exam at the end of his or her high school years. And the results of that test, these are very high stake tests, because they decide who is going to be admitted at best universities, including our university, HSC. And there is a whole lot of data available for this exam. So might be a good idea for you to keep in mind. And the HSC University has access to some of the data sets which are not otherwise available in public domain. And there are people, I'm sure, in this audience that might be able to tell more about this to you. We did some analysis with this data to study other aspects of occupational choices, but you might want as well to have a look, just because there is a huge, huge number of observations. So you can probably learn a lot from that data set. Terrific. Thanks very much. So Bernardo, conventionally, please once again tell us what's coming up next, and we'll adjourn.
Yeah, well, first of all, thank you very much, Silvia, for your presentation. Thank you for staying until after 3 a.m. In Australia.
Oh yeah, right, so, down under.
And well, next week we have Mikhail Drugov from New Economic School, and he will be presenting Hunting for the Discouragement Effects in Context. And Victoria already sent the link of the announcement in the chat if you want to see more details. But basically next Thursday, same time, same place. So, well, thanks everyone for joining. Thanks for the hopefully useful discussion for Silvia. Yeah, we will see each other next week.
Terrific.
Thank you very much for
everyone.
having me.
Bye-bye.
Have a good evening and
good
good
morning.
night.
Take care. Bye.